Thank you for this opportunity. I would like to thank the management and the Department of Mechanical Engineering for giving me an opportunity for presenting my ideas on the topic of recent trends in mechanical engineering. Before I start, I just want to confirm that is my audio clear for everyone so that I could proceed.
Yes, sir.
Without any delay, let me. Okay.
ஓகேவா ஒண்ணுமே கேட்கல இங்க வா
Okay. Thank you. Let me start presenting mechanical engineering. Okay. So there are main trends which I believe that will shape mechanical engineering in future. So actually mechanical engineering is cool, very much cool, and is implemented in almost all aspects of a day-to-day life. So before we start, I'm not sure what kind of target audience am I speaking. Are they entering mechanical engineering or I'm not pretty much sure, but I'll keep my presentation as simple as possible so that everyone would be able to understand the concept as simple as possible. Okay, so before I start, let's discuss what mechanical engineering is all about. What mechanical engineering is all about. So mechanical engineering is nothing but design, building and testing of something. Okay, turn around, look around, there will be so many items around you which are designed by mechanical engineering and which would be futurely designed by you. Okay, the major objective is to design, build and test, and the ultimate objective is to have performance. I'm not able to write properly, so I'll write in short, right? So we want performance, cost, reliability and efficiency. This is what we will always be targeting as a mechanical engineer. So for example, if you are designing a water bottle, so what is the material you need to choose in order to make the water bottle? So for that, you need to consider different criteria. Does your water bottle need to arrest thermal conductivity, or water bottle wants to be always in a cooler temperature, warmer temperature, be unbreakable? Considering the cost, you wanted to make at a low cost, considering design, what kind of design you wanted, all you are deciding according to the parameters. So as a mechanical engineering, we always look into the parameters, and according to the parameters we tend to design and check our design, and once our design is evaluated, we tend to build and test on it. So that is basically what mechanical engineering is all about. Okay, now let's go into different trends. Okay, I will be covering about 7 trends. There are many, but I wanted to keep it short. So let's discuss about these 7 trends which I consider to be the most important. Okay, so the first trend is smart factories and smart robots. Okay, smart factories, smart robots, what are those? In order for you to simply understand, you would have seen clippings of Amazon warehouse where there is no human intervention, everything is processed and handled by bots. Okay, so we need to understand what robots and machines are. What is the difference between a robot and a machine? Okay, machine is something which helps us to perform movement or action or anything which gives us efficiency. That is a machine. But a robot, that machine with some intelligence, is a robot. Okay, for example, let's consider a vacuum cleaner. A vacuum cleaner is a machine. Okay, vacuum cleaner, I'm writing in short. Vacuum cleaner is a machine. Okay, but this vacuum cleaner can be a robot also. Nowadays they are selling this vacuum cleaner robots which automatically cleans the floor. But whereas a normal vacuum cleaner needs a human intervention, where the human has to brush along with the machine. Whereas a robot is autonomous, it acts by itself and it performs. So that is robot, and that is a mission. And now we are coming to an age where intelligence is given to this robot. So consider before intelligence, we had vacuum cleaner and we had vacuum cleaner robot. And if you connect this vacuum cleaner robot to the internet, and you call this as IoT, Internet of Things. Okay, this you call it as IoT because now the robot is connected to the internet, and with the internet, we are able to control that robot. We can program the robot to operate remotely, and at what time you want, you could do it. You can turn on your AC. So AC is nothing but a mission, but we are connecting that mission to internet to make it as an IoT, Internet of Things. Okay, so that was the progress, and from Internet of Things, now we have come to an age of AI. So artificial intelligence. So what artificial intelligence is? Giving intelligence to the robot. So the job of a robot is to clean, right? Here, a vacuum cleaner robot, the job is to clean. So it does by itself. Now, if I give intelligent, what does intelligent means? If the robot can learn and act by itself, it is called as artificial intelligence, right? If the robot can learn and act by itself, it is called as artificial intelligence. Learn and act. So how, sir? Every sir or a vacuum cleaner robot வந்து learn பண்ணி அதுவே act பண்ணலாம். Okay, so we have covered IoT. Now let's give more intelligence to that vacuum cleaner robot. So if the robot is able to decide when to clean by itself, or if the robot is able to sense the outside environment by humidity sensor or dust particles with that kind of a sensor, if it is able to sense and act by itself, turn on itself and turn off itself without any human intelligence, that is artificial intelligence. So now we have come to a stage where we perform that task. Okay, so other than the main difference between the machine and a robot, now just we'll have a brief idea about different evolutions of industry. Okay, industry 1.0 was mechanization. This was the 18th century it started. The most important thing is steam engine. Okay, the old railway thing was driven by steam. How did it happen? They burned coal. The coal boiled the water and produced steam, and this steam helped to run in the engine. So this was repeatedly assembly lines. Automobile was development in this industry 2.0, mass production. We had lot of assembly lines, and still now we have assembly lines, and with that assembly line human used to work. Now robots, the whole assembly line is automated. That was industry 3.0. This was established in 1970. Here PLC, electronics and IT played a major role. Okay, so we have a conveyor and it was automatically run where cars were made. And we also had robots which weld, robots which assembled, robots which reduced the effect of human intervention and helped labor. After that revolution of industry 3.0, there came an industrial revolution 4.0. This connected all the machines and robots to internet. Then came cloud computing and were able to centralize the information. So what is happening in a warehouse? What is happening in a production plant? The whole data was brought to a single computer where people used to analyze and take a decision. Okay, so this was able to achieve by connecting the devices to internet. So now we are at an industrial revolution of 5.0, and this is rapid. At a rapid pace it is developing, and it is changing at a rapid pace. Okay, the next few years of development are going to be very crucial and going to be really fast. Technology will change. A lot of technology will be absolute, but will always be in progression. It will make our work easier, simpler, faster, efficient, and productive, highly productive. So this is basic about different industrial revolution. This is going to be a real game-changing industrial 5.0 as we see a lot of jobs are done autonomously by robots, and we have something called as agents, AI agents. So a new term is being referred, AI agents. So in this revolution of AI agent, you give a task to an AI and it searches, it does the research, and it finds solutions and it implements the solution for us. So it does research, it finds solution and implement the solution for us, making more efficient and cost effective. And it's a revolutionary thing right now. We are at the industrial age of 4.5. So this will be a future. And the next trend, which will be really game changing, is 3D printing, or it is also called as additive manufacturing. 3D printing is not a new technology. It has been established in 1980s, but it is not commercialized because it was under a developmental stage. Different process came. Okay, so for those who does not know what 3D printing is, 3D, right now everyone should be knowing what 3D printer is because it has been commercialized. You can buy 3D printers in the market, easily available, and try to additively manufacture small parts. I would say that development is still a long leap ahead, but right now we are able to do testing and prototyping with it, not in a full process. So I just want to make sure that my audio is correct and audible one more time because I don't want to be staring at a screen and talking. Is my audio available? Audible for everyone?
Yes, sir.
Okay, thank you. Thank you for your reply. I'm really happy that people are replying to me. Okay, so let's go into this 3D printer. Okay, there are 3D printer also have evolved differently over the years. It started in 1980s. I have rounded it. So that's the invention phase. That phase, stereolithography, SLA model. So what is the SLA? We'll just touch what these models are. I'm not going to go in depth, but let me touch what this SLA are, different models of 3D printing, because a lot of people or a lot of students would be interested in 3D printing and it has a lot of scope in future. So SLA is nothing but the first technology what 3D printer gave to us. SLA is nothing but a resin. Now people know what resin art is. Okay, Naraya weddings you give them photos, they put those photos in the resin, put some flowers and pour that resin, mix with some hardener, and after that you get a shiny, glossy product. So this resin can be used for floors. So that is basically a resin. Consider it as a white color liquid. Okay, it's actually a chemical, and that resin cannot be used separately. It has to be mixed with hardener. Okay, so on the mother resin, if you have it in a container, and I told you that you need a hardener in order to make the resin solid. So what they do is they inject this hardener at a specific space. Or big jar you have this resin, and with very precise accuracy, you inject a hardener at a specific place. So what happens is wherever this hardener goes, and it gets solidified, and you get a printed object. The quality was not that great, but the accuracy was good. But this was not really adopted in industry. In 1990s, the next model came. This is a very much known model, FDM, Fused Deposition Model, and SLS, Selective Laser Sintering. Okay, so fused deposit model is nothing but right now you would have seen right in all the DYE stuff and all. If you want to print a 3D printer, you can buy a printer. In that printer, they give you a roll where the filament is rolled, and this filament is fed into the heater of the 3D printer machine. What happens is this thing heats, the nozzle heats, And according to the design, the nozzle keeps on heating and it gets solidified when it cools. So this is the model which is widely known by people and it's also used. Selective laser sintering is nothing but like pouring a powder and using a laser in order to heat that powder to solidify. It does not melt as in FDM process, but what happens is it just fuses. So ஒரு layer of powder போட்டுட்டு the laser will go on through a path, and again a layer of powder will be added, and again a laser will go through the path. So by this process it gets hardened. Okay. So adukapram what happened was this technology went to open source. Then what happened? You were able to download all the models online and just directly print it. It's just giving a command control P. And the technology portion. In 2010, it become more consumable friendly, came into a market. And what happened was we were able to use multiple filaments, multiple materials, and we are able to do it in different colors. And metals also now we do. Nowadays also house is being constructed by 3D printers. There's nothing but instead of this filament, concrete is being poured through the nozzle, and the nozzle keeps moving through a particular path. Okay, so this 3D printer is also quite interesting. First we need to design the model. It was the earliest stage, design the model. And then designing the model was tedious. Adukapra what happened was there came a scanner. There came a 3D scanner where the scanner rotates around the object, gets a 3-dimensional view, and this was converted into a model by itself. Adukapra the next technology came was it was able to print it in layers. On the layers, it is not always a solid. The decision was taken by the software to make some parts solid, some parts as hollow, in order to reduce the material and speed up the processing time. On the technology nowadays we have advanced. Now we are in the advanced stage of 3D printing also. AI powered slicing. Okay, slicing is nothing about you have a 3D model. My machine head has to move right on a horizontal plane. So on the horizontal plane, or slice up. If you have a 3D model, if I want to slice it into a different layer, and that is the path with which it moves. So slicing was a big headache. Nowadays, AI is doing that slicing. It is deciding what should be the path so that the maximum strength is there, and with minimum material and fastest time it could print. And hybrid printing is also something new. Hybrid printing is a combination of cutting as well as metal addition. People would have known what laser cutting is. Laser cutting. So this technology plus 3D printing is now done. Okay. So other advanced in medical. I'm in medical field. So I'm more interested in bioprinting. The future is all about printing tissues. So right now we are printing plastic, we are printing using materials and concrete, metal. We are doing that. The future will be printing, bioprinting, that is tissues, cells and tissues. With this, we are expecting that we can print a whole organ. Okay. So look how great this technology will be. It will be saving a lot of life in medical aspect, prosthetics aspect. Fingers cut, you want it, you can really print that with real cells and fuse it to yourself so that it feels like it's you. Okay, so I'm really going into this. I'm excited to see bioprinting in future. Okay, that's the second trend is 3D printing. So let's go to our third trend, which is smart design. Okay, smart design. So third trend, and I'll say that this is also rapidly evolving. Here, students would have used 2D software, 3D software, ANSYS, where you analyze the product and then you develop. So now has been changed. Initials we had AutoCAD 2D. Okay. So then what happened was 2D become 3D. That was the development. So after developing a product in 3 dimension, we were able to export this to different other machines like CNC machines, CNC laser cut machines in order to cut a particular profile and do a certain kind of operation. So after this 3-dimensional software came, then something came the ANSYS, analyze panano. The items which we design, let's give some force, let's give some tension, let's give some pressure, and let's check how this item functions. Appadi maaridu irundha our design. Adukapramma, now we are in the age of generative design. I have highlighted this, right? Generative design in yellow color. Generative design is a really great topic because designing concept has been changed. For example, if I wanted to design a chair, right now it is not necessary that you need to design a chair from scratch. Okay, so I'll give a small example. If I am doing an event, I am into an event management business. Okay, event management business. Event management. Okay, for my event management, I need to design a stage and have chairs so that people could sit and have the comfort. So I have to design chairs. These round things are chairs. Assume that these are chairs. Okay. So now, as an event manager, what do I do is I don't do only one event. I do many events, right? So these I need to transport these chairs to different locations. So what kind of a chair should I have? Now that's the question. So should I have a chair? What is my requirement, I should say? Because I want to maximize the space. Maximize the space. I want to accommodate more number of chairs in a particular region. If I transport also, I must make sure that the size and the dimensions, I could push many chairs into a Tata Ace or any transport vehicle so that my transportation cost comes down. So my objective is this. So what will I do is, right now we are in an age where this is happening. I will be taking models from online. I'll put it into the software and ask the software to design for me. Right now we are in a stage that we are not designing. We just give a reference. And the software designs by itself. I give a reference and the software design. Sir, எப்படி புரியலையே நிறைய பேர் கேட்டீங்கன்னா இப்போ நான் ஈவென்ட் மேனேஜ்மெண்ட்டுக்கு I need to have many chairs. So I will just import a chair model from online and give it to my software and I'll just say conditions. எனக்கு என்னென்ன கண்டிஷன்ஸ்லாம் இருக்கலாம். I want to stack chairs. Okay, in an effective way. நீங்க பார்த்துட்டே போலாம், when we have marriages என்ன பண்ணுவாங்க, ஹாலுக்கு வந்து we'll bring up many plastic chairs stacked one on one and when we need it we just do it. So stacking, so இப்படி stack பண்ணா I can stack more number of chairs. சேரோட சைஸை எப்படி குறைக்கலாம் without losing the load capacity of a chair. Okay, if a person sits, at least 150 kg person should accommodate in the chair properly. So according to that, it will design the width. It will design the size of the legs of the chair because it is very crucial. Chair legs should be designed and the width and the height, the back support. This I will give as an input and I will ask to generate. So it would generate different models. It will not generate one model, two model. It will generate 10 to 15 models. That is what generative design is. It keeps generating itself. Whichever model you feel is comfortable, you can choose. Now AI is deciding which model is more effective. If you give proper prompts, if I say that I need to have a chair where 150 kg of load should be easily accommodated and it should be easily stackable, it should have small area, the making cost, the production cost of the chair should be less. You give all the input, it generates so many designs and it gives an output, and from that you can extract different parts, generate part model and start building that very fast. ஸோ இதுதான் டிசைன்ல ஒரு நெக்ஸ்ட் level of change you can expect. Already graphic designers are experiencing this thing at first, as our AI tools are making are able to generate great visuals with normal prompts. The same thing, all the AI stuff will come to software also. So that is the trend 3, which will be going crazy. Which will be going crazy. Okay, let's go for trend number 4. I don't call it as a trend, but this is very important. People will be focusing about this very much. Going green is the future, because as we know that our manual cars are right now being replaced by electrical vehicles very rapidly. More than 2-3 years ago, I was not seeing that much of electric vehicles on road. Right now, it's flooded with scooties, electric scooties. Electric cars are into our market itself. So it is very much penetrating in our market very fast. So this has to be taken into the account. Why this thing is happening? Because if you drive, people say because you drive electric scooters and electric vehicles, you will be able to pollute lesser. But that is not the truth actually, because the energy powered needed to power the electric vehicle can be polluting, right? You can burn coal, get that energy and convert that into power, and you be using it. So that defeats our purpose. But okay, we are moving to that, and it is very important to move towards sustainable green energy, because we experience a dramatic climate change in Chennai itself. Chennai used to be hot, and it is still hot, but not that hot as before. We are receiving unexpected rains and showers and unexpected floodings. So these are the main reasons why we need to focus, because we need to take care of our future, and we need to protect and pass it to our future generation also. So this green energy design is developing solar windmills, turbines, hydroelectricity plants in an effective way. The whole point is to reduce energy consumption. You can make your home also a green energy home. Green building solvanga. Green building certified. If you have a big company, they would ask you to certify that your building is a green building, because you will be using lot of resource. Correct? Or peri office la, if you have lot of computers, lot of machines, what is happening? It's actually consuming lot of energy, and the energy which is being consumed always causes a pollution somewhere behind, because that to make that energy we burn something, or we burn fossil fuel, coal, we get energy from that also, petrol. Okay, so that has to really change, and you could design your house in a green energy efficient building by adding some of the small elements. If you have a terrace, I would do, if you are living just below the terrace, the top floor, what I do is I put a tarp on the terrace, place 4 bricks and pour little bit of water, so that the heat temperature does not come down. So if the temperature is not that hot, you will use less of AC, less of fan, natural cooling, so thereby polluting less and saving our environment. So this concept of green energy is very much needed, and I would recommend students to do projects on this, because it is the need of an hour to save our planet and to go forward. So that is trend 4, which I think will be a great hit. So the trend 5 is materials that think smarter. So what's a material can think smarter? Yes, there are some materials which can think smarter. Okay, it can react to the environment, it can change to the environment. So I'll just give a small example that everyone could relate. Okay, so if you're buying a very expensive car or a bike, it will be very glossy when you buy the first time, and you will take care of it each and every time when you use. Okay, தெரியாம யாராவது ஸ்கிராச் பண்ணிட்டாங்கன்னா உங்க வெஹிக்கிள, what will happen? You can't tolerate that, because we will always consider that thing, the car or the bike, very close to us. If someone scratches, it is as if your heart gets broken, right? So in order to protect that, there is a material in the market. So it is called as PPF, paint protective film. It is called as PPF. யாராவது பைக் ரைடர்ஸா இருந்தாங்கன்னா this term people will know, bike lovers, car lovers, because they take care of their bikes and cars, right? So they buy products like waxes, polishes, shampoos in order to maintain the vehicle. So in the paint protective film is a smart material. So why I call this a smart material? It is nothing but a transparent kind of sheet. This paint protective film is nothing like a transparent sheet. What they do is they paste the sheet on the vehicle. They wrap it. Vehicle wrap பண்ணுவாங்கன்னு கேள்விப்பட்டிருப்பீங்களா? Modify பண்றவங்க they tend to wrap it with different sticker model. Same way with this paint protective film is a transparent sheet. With that they wrap their vehicle completely. So what happens is when you have dust on it, நிறைய பேர் என்ன பண்ணுவாங்க, they have a habit of taking a cloth and cleaning it. Actually you are not supposed to do that, because doing that will cause lot of scratches on the vehicle. So if you have a paint protective film, the scratches will be there on the film, but the material in such a way that when it gets heated up, the cracks heal by itself and the film will get healed by itself. So ஒரு காரின் எடுத்துட்டா நீங்க வெயில்ல ஓட்டி தானே ஆகணும். So what happens is when you take the vehicle out, the heat falls on the scratches on the film. The film will protect your paint. Okay? And the scratches will vanish. The film will be uniform once you expose it to heat. So this material is a heat sensitive material. It is a smart material. Okay, it is a smart material. It changes or reacts to the stimulus. Okay, so this material, the technology in this field will also be a game changer, because we tend to buy expensive mobiles and we use tempered glass, right? The purpose of the tempered glass is to protect our mobile display by sacrificing its tempered glass to break when something hard happens, but it should not be scratchable. That is, it has to be hard. Hard things will break easily, but are resistant to scratches. For example, take a glass and take a polycarbonate sheet or acrylic sheet. Take a sandpaper, try to rub on all three things, and on rubbing you can see visible scratches on acrylic and polycarbonate sheet, as well as less scratches on glass, because glass is more harder. So it is a stronger material. So smart materials will play a great role in future. And the next trend is digital twins. Okay, so for this I'll just explain a small concept. I'll tell a small story. Okay, what is this digital twin, sir? Real life twins, na we know. Real life twins is two people looking alike. So digital twin is nothing but a duplicate of a real version digitally. Okay, so abdina enna, for example, you have an engine of a car. It is a physical thing, right? So in the engine, if I have a twin, the engine, if I take it to a digital world, it is called as a digital twin. Okay, I'll give a much smaller example. The use of this one. Consider I get a heart attack. Okay, God forbids, let me be alive for a long time, but this is the scenario. Consider this thing. If I have a heart attack, I'll go to the hospital. Doctor checks me and he says that in the heart there is a block, and the block has been removed, and you need to stay careful for the rest of your life. Okay, so I need to be careful for the rest of my life. So now doctor comes with an idea. So let us make a copy of your heart digitally and simulate what will happen, what could be the future damages or future causes of any blocks. So For this, what happens is we need to take data from my heart. So இப்பெல்லாம் நம்ம பார்த்தோம்னா like a needle like thing people put there in their arm, so that is able to uh, monitor blood pressure, blood sugar. That is able to monitor blood pressure, blood sugar. Okay, so under my device, if I attach, it monitors my blood pressure. That is the most important factor for any heart problem. Pressure ஜாஸ்தி ஆச்சுன்னா something is wrong. Your pump is not proper. அது details எடுக்கலாம். Sugar levels எடுக்கலாம். Sugar levels எடுக்கலாம். I can measure the rhythm of my heart and take this data to digitally and model a digital virtual heart. So on the virtual heart level, you can simulate what will happen if blood pressure is on this level itself, sugar at this level itself. If it is, sorry, I have a bad throat. So blood pressure, blood sugar, idey level la irundhuchna, what will happen to my heart? I can predict. The doctors will able to predict what will happen, how long could I live, what all the complications could I have. Knowing that could help me in my therapy. Okay, so if the problems la vara vaaipu irukna, according to that I can change. According to that I will be able to change. That is the concept of digital twins, a virtual copy. For example, என்னொன்னு சொல்லலாம், so உங்க இன்ஜின்ல இருந்து வர டேட்டாவை I can analyze and make a twin digitally. So இன்ஜின்ல இருந்து வர டாக்ஸிக் இல்லாட்டி unburned carbon measure பண்ணிட்டு I could say that what will happen prolonged over the period of time, what damages it could have, and it could help me to preventively maintain any further damages. That's the whole concept of digital twin. Digital twin. Okay, so this is a buzz. Digital twin is a buzz topic right now. People are talking about this. It's a buzz topic which is very much expected to explode in few years, upcoming years. The seventh and the last trend, what I am really interested is in the small nanotechnology, MEMS technology. So right now government is also launching lot of schemes for this MEMS technology. So if you are launching any business, if you are making any thing using MEMS technology, அதாவது MEMS technology is right now nothing but chip development, chip assembly, boards assembly பண்றது. அதுதான், that's the technology, because it involves lot of nano stuff. உங்க chip, CPU processor, GPU எல்லாமே. இப்போ chip war, we are talking about chip war. US has sanctioned China to receive their NVIDIA chips. So China is trying to make their own chips because they know that whoever control this will control the whole market and whole world ultimately, because with this only they will be powering artificial intelligence. So adanal this technology is something which you can expect to boom. Okay, this technology, it's all about nanotechnology, doing things in very, 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 very small sizes. Okay, so and the last, I would like to tell about the future. How is the future in mechanical engineering? The future in mechanical engineering is always exciting because it will always exist, as it is an evergreen field, and all technology will be dependent on mechanical engineering, because everything has to move, everything has to do something, convert energy. So mechanical engineering will be pairing with AI in order to advance machinery, in order to produce advanced machineries and capabilities. With all said, I think I'm done with my presentation. I have kept it quite small with 7 slides. I would like to thank again for the Department of Mechanical Engineering and the management of SAEC You gave me a great opportunity. It's been a while I've been presenting, but I thank again all for giving this an opportunity. So let me check how to stop sharing my screen. Am I still sharing the screen? Okay. Thank you. I'm done for the day. If you have any comments, please you can let me know. Aishman, thank you. Thank you for your thumbs up. Thank you all. So I would request the host to conclude. Sorry for my voice. I have a bad throat. I was not able to consistently speak. Thank you everyone for your appreciations. Thank you.
Hi, sir.
Thank you, sir.
This is Krishnamurthy.
Thank you, sir.
Dear participants, kindly fill out this form. Praveen, sir.